This is Algebra Lesson 10.4, Stretching and Shrinking Graphs. So the transformation that we're going to talk about today is a dilation, and that would be taking a graph and stretching it. And we accomplish stretches through multiplication. If I have a function and I multiply it by some value, it's going to stretch it vertically. If I have a function and I divide it by some number, that's going to stretch it horizontally. Now I need to be specific that multiplying by a number, I mean a number larger than 1. If I multiply by a decimal, that's the same as dividing by a whole number. So multiplying by a number bigger than 1 is going to stretch a graph taller, but multiplying it by a decimal is going to stretch it wider, because a decimal would not be a number bigger than 1. So my first example here says sketch a graph of each function as a transformation of y equals x squared minus 2. So I have the original graph here. I know it's quadratic because I see the power of 2. I know it's down 2 from the origin because I see the minus 2. And if I take that graph and I multiply it by 2, it's basically going to take that same graph and stretch it so it's a little skinnier. It got stretched taller. If I multiply that graph by a 0.5, it's going to take that original graph and it's going to stretch it wider. If I do a negative 2, it's actually going to do the same thing as the first. It's going to stretch it taller. But we did negatives on the last lesson. A negative reflects the graph vertically, so it's going to flip upside down. So it's skinny like this one, but it's upside down because of the negative. And that's the extent of our stretching. We're either going to stretch it by a bigger number to make it taller, or a smaller number to make it wider. I have another example, and I just want to write an equation for this graph. So I see the graph, I see that it's a U-shape, it's a parabola, so I know I need to use the parent function y equals x squared. Normally that's going to go through the origin, but this graph moved 4 units to the left and 2 units up, so that is y equals x plus 4 squared plus 2. Now a normal parabola is going to have a 1-to-1 right here, but that's a little bit off. This graph got stretched skinnier. So what we do is look for the nearest point that's right on the whole numbers. I'm going along the line and just looking for the first point that I see that's going to fit right on the grid marks. And then we do rise over run. Slope. So this is 1, 2, 3, 4, 5, 6 up and 2 over. 6 over 2, rise over run for slope is 3. So I'm going to multiply this equation by 3. And that's it. So, good luck on the exercises. Let me know if you have any questions.